So let's go to our second part of this exercise, which is exercise part 1b, and there we optimize the ridge regression. So we should derive the formula for fitting the vector of parameters beta hat ridge of a multivariate ridge regression, and afterwards explain the difference between beta hat ridge and beta hat OLS. So let's start here. What has changed? Well, our objective function has changed. And now it looks like this. So the first part is the same as before. It's the sum of squared residuals. But the second part, now we add up, and we add this part here, lambda, times the sum of the squared betas. And this is our L2 penalty, which penalizes complexity in the model. So let's rewrite this in matrix form. So this is the sum of squared residuals plus lambda, which is a scalar, so don't indicate it bold, and then the sum of squared betas. Now how do we optimize our betas here? Same way as before. We optimize the vector of our betas by minimizing the projective function. And we do this with the first order conditions again. So let's take the derivative of the projective function in respect to our betas. That is this derivative, the derivative in respect to betas of epsilon transpose epsilon of lambda beta transpose beta, and that's now equal to this term. Okay, now I just plugged in the estimation model here, or like the restructured estimation model, so I can plug it in epsilon. Now we want to take this and set it equal to 0. So we optimize it. Now we can just take the derivative again as before. Maybe let's write this out again. So it's the derivative in respect to beta of y transpose y minus 2 that should be equal to 0. Okay, now let's take derivative again, and the first part is the same as before. So this will be 0, then this will be minus 2. And now this will be 2 lambda beta equal to 0. Okay, now we know again that x transpose x is invertible. So let's restructure this. Now all the 2's can be you can divide by 2 and then they all disappear. Now let's exclude beta here. Now if we take this part to the other side, then we will end up with our optimal beta. Okay, so if we now assume that our features are standardized and orthogonal, then x transpose x is equal to the identity matrix. And now if we plug this in, okay. Yeah, we should plug this in obviously. We can now exclude x transpose x from the parentheses. It should be -1 here. Okay, and now we see that this is just our vector of all S betas. And this is now a relationship between the OLS betas and the betas from the ridge regression. Ridge regression penalizes complexity, and this we can see in the denominator here, which biases or adds bias to the OLS estimator. This is what we also discussed last time, is that the ridge regression will, with its penalty term, introduce bias or increase the bias and also reduce its variance.